In this video, I'll describe the Arduino IDE. IDE stands for Integrated Development Environment. It's the app that allows you to write and to edit programs and to compile them into machine code and then to download them into your Arduino board. I'll do a simple demo which will measure the voltage level of some input, such as a sensor, and turn on an LED when the voltage exceeds a threshold. It'll also display the voltage. Start by downloading the Arduino IDE. This is an app that runs on either Windows, Apple, or Linux. There's also a browser-based version, but I recommend using the app itself. Here's what it looks like when I start it up on my Mac. This window shows the program that you are currently writing or modifying. This one happens to be called Blink. And you can edit things just like normal. So, for example, I can scroll down and I can type a few characters. I don't really want to do that just yet because I'll modify things later. Also, watch out for this little arrow right here. This allows you to hide things to make it easier to deal with larger programs, but just be aware that that's there. Now take a look at these two buttons here. This one is called Verify, and this one is called Upload. Verify will compile your program and check it for errors, and the Upload function will do that as well as transferring your program into the Arduino so it can be executed. So if we just click Verify, we see this little sub window opening up here, and it says Done Compiling and tells us that our program, which they call a sketch, uses only 924 bytes. And now let's introduce an error to see what happens. So I'll just type some random stuff. And again, I'll click Verify. And let's expand this. And we can see a number of error messages. And when you've got errors like this, you'll need to sort them out. This one says compilation error. This thing does not name a type. So I can close this if I want. Or I can close this entire window if I want. And now let's fix the program to where it was and re-verify it. And it says Done Compiling, and there are no error messages. So again, I'll close that little sub window. If it bothers you, you can close it, or you can keep it open. Next, let's take a look at these menus up here. The Edit menu contains the normal sorts of things that you're used to on your computer, and you can use these to edit your program. We've got, undo and copy and paste and so on. I'm not going to go into this. The File menu contains entries to create a new program. In Arduino, the programs are called sketches for some reason. You can open existing ones and you can close and save your program. Examples is something important and different about the Arduino. The IDE comes with a bunch of built-in pre-existing programs, and they're categorized here, and you can see there's lots of different things. And if you are looking for some particular kind of I/O device, there may very well be an example program that will show you how it can be used or controlled. Let's go up here to Basics and look at Blink. So if I open this, then that example program will be opened in a new window. And this is just the Blink program that we're already looking at, so it's just a copy. I don't really need a copy of this in a separate window, so I'll go ahead and close this now. Now let's go ahead and download this program to the Arduino and execute it. Arduino calls this the upload function. I think download is the more correct word, but in any case, we're copying it from the laptop to the Arduino. So far it thinks we've got an Uno board, and in fact I've got a Nano Every board. So let's go ahead and plug this in. You can see that on my Arduino board, the LED is already blinking. It turns out that all brand new Arduino boards come with the Blink program already pre-installed. Before we can do the download, we have to let the software know how we've connected the Arduino. So going up to this Tools menu, we can go down to the Port option, and we see the various ports on this computer. And this is the one where I've connected the Arduino, so we'll click that. And we also need to let the software know what kind of a board we've got. And so we can go to the Boards option, and there are AVR boards and there are Mega AVR boards. And we select one. and it turns out that the Nano Every is a Mega AVR board, so we'll click that. Before I download the program, note that the LED on the board is already flashing. It turns out that every brand new Arduino board is shipped with the Blink program already pre-installed, so we're not going to be able to see whether we're properly downloading. So what I'm going to do is I'm going to go up to this program and I'm going to modify it. This thing will turn the LED on and leave it on for 1,000 milliseconds or 1 second, and I'm going to change that to 500, and then it will turn it off and then wait for another 1,000 milliseconds or 1 second. So I'm going to change that to 500. Now we should see the light flash much faster. Now when I click the upload button, it will both compile and check the program as well as download it. So we'll do that. It's compiling, it's done, and it's uploading. And for some reason I'm getting this message in red. It doesn't seem to be a problem because now, as you can see, the light is flashing twice as fast. So I think it's always good to verify that you can compile and download a program before you start working on a more complicated project, just to make sure your setup is functional. We've modified this program, so let's go ahead and try to save it. And if we go down here to save, it pops up a thing that's asking us to rename it. So let's call it Blink Faster, and we'll just save that. And now we've got our Blink Faster program. It won't allow you to update the example programs. Now let's focus on this little demo project. And with every project, we need to start with a schematic diagram. So let's show a schematic diagram for what we're going to construct here. Here's the Arduino Every board, and it's connected with a USB to the laptop. And we've got a power and ground connection. We're going to drive a 4-digit 7-segment display, and that will use 7 pins for each of the 7 segments and 4 pins for each of the digits, so 11 pins total. And we are going to drive an LED, and so here I've got the LED with a 330 ohm resistor, and we're going to measure some voltage. So here in this schematic diagram, I'm showing a variable resistor. So this is also called a rheostat, and we can adjust it to get a voltage between 5 volts and ground. And so we'll be looking at that voltage and displaying it on the display, and when a threshold is reached, we'll turn on the LED. Now let's take a look at the pinout for the Arduino Every board. Here you see the USB connector and a green LED to indicate it's got power, and a yellow LED which is currently blinking. Over here we have a bunch of digital pins, D2 through D12. There are exactly 11 of these, so that's why I chose these for the outputs to the 7-segment display. And beyond D12 there's D13, which I chose for the LED, and so beyond D12 there's D13 over here. These digital pins can be used either for input or output, but they're digital. They either transfer a 0 or a 1, with 0 being ground and 1 being 5 volts. There are also some additional pins over here, D14 through D21, which can also be used as analog input pins. When they're used as analog input, they're called A0 through A7. And the idea with the analog input is that the Arduino can read the voltage that's supplied to that pin and measure it. And so we'll be using A0 as our input to be measured in this little demo project. The Arduino can get power from either the USB or this VN, voltage input pin, down here. Note the arrow is going toward the board. And you can have both these connected at the same time. That's okay too. It also will supply both 5 volts and 3.3 volts to other circuitry. So you can pull off 5 volts or 3.3 volts if you need it. The notation 3V3 means 3.3 volts. And we see a similar notation with resistance, like R3 would be 3.3 ohms. We've got ground and reset pins over here, and these are electrically connected to the other side as well, just for convenience. The reset signal has a bar over the top of it, and whenever you see a bar over a signal like this, it means that it works with negative logic. So normally you'd think that you would pull the reset pin high to reset the Arduino, but in fact you pull it low to 0. You ground it to reset the Arduino board. And resetting it will cause your program to start over from the beginning. And so you can run your program even when the USB is not connected, as long as you're supplying voltage in down here. There's a pull-up resistor internal to the board on this, so we can just leave that unconnected and it will be high at all times. And if you want to manually reset the Arduino, that is, you want to restart your program, you can just push this little push button on the board. We also have these two pins down here, which used to be called D0 and D1, and these are concerned with transmit and receive for a serial connection, and so we'll just leave those unconnected. Now let's take a look at this LED with the 330 ohm resistor connected to digital pin 13. So here's the Arduino, and you can see that I've connected the LED to D13, which is this pin here, and it goes over to here where it's connected to the resistor, and the resistor goes over to the ground pin. Note that the two ground pins are called out with a little extra white paint to make things convenient. So what happens when I plug this thing in? Well, it immediately starts flashing, and you notice that this LED and the onboard LED are flashing exactly in unison. And that's because the onboard LED is directly tied to pin D13. And we can also reset this thing. While I hold it down, it's not executing the program, but when I release it, it starts executing. Next, let me talk about how we program the Arduino by going through this blink program. It begins with a comment. Everything from a /* through the following * is a comment and is ignored. So we see a description of what the program does and some names and dates. And then scrolling down, we see that we also have another way to comment things, which is //, and that goes through the end of the line, like we see here and here. Every Arduino program will have at least two functions, and many of them have just two functions. One is called setup, and the other is called loop. And each of these functions is a void function, so we see the void keyword, as well as the function name. And there are no parameters, so we have these parentheses here. And then we have an open brace, and then everything in the function follows that to the closing brace, which must match. So the setup function will be called once when you press the reset button or you supply power to the Arduino board. And so it will do whatever is in the setup function. Then, after that, the Arduino will continually call the loop function over and over and over until you turn the power off. And so in this particular case, we see one statement in the setup function. Statements run through a semicolon, and every statement ends with a semicolon. Pin mode is another function. It's a built-in function that will define some particular pin on the Arduino as either an input or an output. And this name here, LED built-in, is a predefined name that you don't have to name, but it's equated to some number. So if I wanted to, I could just change that to 13. Okay, maybe it would be less easy to read, but it would still work just fine. Output is also equated to some number, but you should use either input or output. And we also see high and low as built-in things. So let me just change that back to LED built-in. And that's basically configures the Arduino so that that particular pin will be driven by the program. We can also have input pins, but this program doesn't have any input pins. We'll see those later. Down here in the loop function, we see a write, a delay, a write, and a delay. The digital write will send the pin either high or low. That is, it will either drive it to ground for the case of low or to 5 volts in the case of high. And so this basically sets the pin to 5 volts, and then we have a delay. This delay here is measured in milliseconds or thousandths of a second, and I've changed it to 500 milliseconds. So really I should fix this comment here to be correct, and this one down here as well. So we wait, and then we change the same pin to low, that is, we drive it back to ground, and then delay again. This function will be called over and over by some other software that you don't really see. You don't have to really worry too much about it. And so it will constantly be doing this in a cycle. It's very much like a loop or a for statement in a program that just does something over and over and over. The Arduino software has a couple of features that will make your life easier. All parentheses must be matched. They must come in pairs. So if you click on this open parenthesis, it automatically highlights the closing parenthesis. And braces must also be paired up. So if you click on this closing brace, you see the corresponding matching open brace highlighted. And same thing down here. The function names are shown in red. So here we have the definition of the setup function, and here we have the definition of the loop function. And we can call, we also say we can invoke functions. So in this line we are calling the pin mode function, and here calling the digital write function, and here the delay function. Functions can be passed arguments, so the delay function requires exactly one argument, which is a number, and that's the number of milliseconds to wait for. The digital write function requires 2 arguments, and whenever there's more than one argument, those arguments are separated by commas, as we see here. The setup and loop functions do not have arguments at all, so that's why this parenthesis list at the beginning is empty. We can also do your standard sorts of things like cut and paste. For example, I can X that out and then I can paste it down here. And that wouldn't change the program because it doesn't matter what order these functions are specified in. It will call the setup function first, and then when your application is running, when the Arduino program is executing, it will be calling this loop function over and over. Now let me just use undo to put it back the way it was. And now I'm going to start writing our demo program. So let's get rid of this comment and let's change it to something that's more descriptive. So we'll say demo program for Arduino video. And we can get rid of all of this stuff. And it's always a good idea to put your name in there and the date. So we'll do that. And we'll just leave the comment like that. And I don't think we need the setup function comment. And we don't need that comment. And we can get rid of this comment and some of this other stuff here, which is sort of redundant here. Okay. And now let's give this thing a new name and save it. So we'll save as, let's call this Arduino demo. And so now it is saved with that new name. Next, I want to describe the serial monitor. This is an excellent tool to help you debug and write your programs because it allows you to print out messages while your program is running. And this is very, very useful. So in order to use the serial monitor, you need to do 2 things. You need to initialize it, and then you need to print messages. So to initialize it, we have to type this, we have to invoke or call this function named begin. We type serial.begin, and I'm not going to get into why we say it like that, but that's just what you have to say. And then it takes a single argument, which is the baud rate. And then we have our closing parenthesis and a semicolon. And then to print something out, we can just say serial.print line, ln, and let's just print hello. And then we have our closing parenthesis and the semicolon. And then let's also print a message out. Whenever we turn the LED on, we'll say on. And whenever we turn the, whenever we turn the LED off, we'll say off. And it's always a good idea to have your statements line up neatly and be indented properly so you can see where you are. With larger programs, that's much more important. Okay, now I think I've got that correct, but I'm ready to download it. And if I try to download it, notice that this is not boldface. That's because my Arduino is not plugged in. And if I plug it in, but I plug it into the wrong USB port, it's still not bold-faced. So if I try to download it, or I guess we call it upload with Arduino, it says that there's an upload error. So I can either move it to the right USB, or I can come up here to the Tools menu and select the correct port. So let's just do that. And now it's in boldface, so it should download properly. But before I do that, I want to go up to the Tools menu and go to the serial monitor. So I'm going to click on that, and that opens up a serial monitor. Let's give it a little bit more room here, and let's get rid of that message. And so when I upload this program, we should see it start to execute. And so there it's uploading, and then it switched back to the serial monitor. You see my message hello here, and then on, off, on, off. And it scrolls, so the current message is here down on the bottom. But that doesn't always happen. So you can see the bar over here is going down, so everything's at the bottom. And my hello message is way up here at the top. Oh, it doesn't want to go up there to the top. But now if I hit that, it's a little bit different. So now I can scroll up to the top. And if you're not seeing your current messages, just try clicking this little thing right here, and that sort of determines whether it's scrolling automatically or whether it's not scrolling. So this print stuff is going to be very important because it's going to allow us to print out values. We can also use this print line function to print numeric values. So let's change this to 1, 2, 3, for example, and when the LED is off, we'll print 4, 5, 6. And you can see we haven't uploaded it yet, but let's go ahead and upload this function and see what happens. So it's compiling, and it's uploading, and now it printed hello. Let me switch this so we can scroll up a little bit and see the transition. It printed hello, and then it started printing 1, 2, 3, 4, 5, 6, and so on. We can also show that these symbols, high and low and LED built-in, are actually values. So instead of printing 1, 2, 3, let's print the LED built-in, and then we'll print high, and then we'll print low here. So copy and paste. And now let's upload, and we'll see what values. We should see 13 here and probably 1 and 0 here. Let's scroll down to the bottom and then scroll. Make this a little bit larger and then scroll back up, and we see that we're printing hello and then 13, which is our pin number, and then we print high as 1 and low as 0, as I expected. So this print line function, serial.println, as well as the adjoining serial.begin, will be very useful for printing out values while the program is running. Now let's go ahead and hook up this variable resistor. Earlier I called it a rheostat. That's a pretty dated term. It's more likely to be called a potentiometer or simply a pot. So one side of it will be hooked up to power, and the other side will be hooked up to ground, and then the middle terminal will be hooked up to the analog input 0 pin of the Arduino. I found this 10K variable resistor, and I'm going to use that. The middle terminal is green here, and as you can see, I've hooked green up to the A0 pin, and I hooked the ground up and the power to V out, the power supply that it goes out from the board. So now let's modify our program to read out what's going on this pin. First of all, I want to get rid of some of this stuff. So I am just going to comment out a few things here that we don't really need. I'll leave the digital rights there to remind us how to do it, and the rest of this stuff I think I'll get rid of. I'll leave that delay there for reasons that will become clear in a second. Okay, now the first thing we need to do is to read the value from the analog pin. And so there's a function called analog read, and it takes a single argument, which is the pin number you want to read from, and that would be A0. Now this function returns a value. Okay, it returns something, and so we need to save that, and we'll call it, let's call it sensor value. That's a nice little name, and this is an assignment statement that tells us we're going to take the value returned from the pin and save it in this variable. Now this variable needs to be defined, so we're going to define it as an integer. That is, it will be a whole number. And analog read will return a number between 0 and 1023. That's just the way it works. Whatever the voltage is, it'll always return a number between 0 and 1023. And so we want to convert it into something between 0 and 5. So how can we convert it? Well, let's see. We need to take sensor value, and if we divide it by 1023.0, I'll explain that in a second, then that would give you a number between 0 and 1. Okay, instead of being between 0 and 1023, it'd be between 0 and 1. Okay, but we really want it between 0 and 5, so we need to multiply by 5. Let's do that. And what I'm going to do is I'm going to say times 5.0 here. I'm doing them in this order rather than multiplying and then dividing, or dividing then multiplying. You can do them in any order mathematically, but if we put the parentheses this way, then the compiler will figure out what this value is. It's some number, and so every time it'll just multiply the sensor value. Now the sensor value is an integer. Okay, it's a whole number, but here we're working with fractions. So what we want to do is we want to make this we want to call this now, let's call it voltage. Okay, and we'll assign it to some variable, but this variable is not an integer value. It's what we call a float. So this is a number that can have a fractional part, and there's a certain amount of accuracy, a few digits, not which would do just fine for us. So this is actually a variable definition. Okay, we're defining a variable named sensor value, and then we're setting it equal to some value, and that value is what we're getting from pin A0, a number between 0 and 1023. And then here we're taking that value and we're adjusting it, and we're storing it in some floating point number that will range between 0 and 5. And the last thing we want to do is we want to print this out. So we can say serial print line, and we're printing out the voltage. So we have that. And then I'm going to keep this delay here. I'm going to shorten it a little bit. If we don't, this loop will be repeating over and over. And if we don't have any delay there, it'll just be throwing numbers out so fast we can't even read them. So if I put a little bit of a delay in here, it makes it a bit easier for us humans to read. Okay, so let's go ahead and compile and download this program to the Arduino. You can see from this that I'm not plugged in, so let me go ahead and plug the Arduino back in. And then I'll click Upload, which compiles it, and looks like it worked okay. And then it's going to download, and now it's printing. There's the hello message. Let me just stop this so I can scroll up here. There's my hello message. You can see some output from the previous test that I was doing. And then it starts printing out a bunch of numbers. So it's just printing out numbers as it goes down here. And so now if I take my potentiometer and I adjust it, you can see that as I adjust it, the numbers are changing. If I go all the way to one extreme, it shows 0. And then as I turn it up a little bit, it gets larger, and I'm slowly turning it more and more, and it's getting larger and larger. And finally I reach the extent, the upper extent, and it's showing 5 volts. So again, we've got a function called analog read that can read a value. It comes in as a number between 0 and 1023, and we're saving that in a variable named sensor value, which is of type integer. And then we do a little bit of conversion on that same value by multiplying it by some value, namely 5/123, which converts it into a number between 0 and 5. And because we've got decimal places there, we've got a decimal point, the compiler knows that these are floating point numbers and not integers. And a floating point number is basically a number that can have a fractional part. And then we save the result of our computation in a variable called voltage. We're defining it here as a floating point variable. And then finally we're printing it and waiting a little bit so that we can read our output. And then when loop is called again, we do the same thing again. And so if I turn my potentiometer, we see that we are measuring the voltage that's on pin A0. Next, let's add the display to this project. Here is a typical 4-digit, 7-segment LED display. And it has a number of pins. In this case, it has 12 pins. And the pins will be numbered D1, D2, D3, and D4, which stands for digit 1, 2, 3, and 4. Digit 1 is the leftmost digit. And then the segments are named A, B, C, D, E, F, and G in this order. And we also have DP for the decimal point. So the remaining pins are A, B, C, D, E, F, G, and the decimal point. So notice that these pins are in a somewhat random or screwed up order. And this is one particular product. Other products may have the pins in a different order. So the next question to ask is, how are we going to drive this display? How does it work? What do these pins exactly mean? So here's what's going on inside of this display. This circuit diagram shows all of our pins, just as before. We've got our pins 12, 9, 8, 6 for each of the 4 digits. So we have digit 1 here, digit 2, digit 3, and digit 4. And for each digit, we have a bunch of LEDs shown here. We have digits for segments A through G plus the decimal point, and we have those for each of the 4 digits. Now remember, with a diode or an LED, they have to be oriented properly. And in this particular case, the anode is on the top and the cathode is on the bottom. Okay, so these diodes are oriented so that in order to light up one particular segment, we need to run current from the top, for example, from pin 12, down through the diode to, say, pin 4. So, for example, if we want to light up segment C, this is C of digit 1, that would be this segment right here, then we would need to run current from pin 12 through the diode to pin 4. So we'd have to drive pin 12 high and pin 4 low. Now, you can see that all of these diodes have their anodes connected. So there are two kinds of displays. This particular display that we're looking at here is called a common anode or shared anode. And that's because the diodes are oriented this way. The current flows from the digit pins to the segment pins. The other sort of display, which is not shown, is called a common cathode or shared cathode. And the circuit diagram would look exactly the same, except for the diodes would be oriented in the opposite direction. So in order to show 4 different digits, what we're going to do is the software will light up the first digit and keep the others dark, and then it will darken the first digit, light up the second digit, and keep the others dark, and then it will darken the first 2 digits, light up the third digit, and then it will light up the fourth digit, and then it will go back and light up digit 1 again. And so it will cycle through all 4 digits over and over very fast, and in reality only 1 digit is lit up at any one particular time, but your eye will fuse them together, so you'll see all 4 digits appearing to be lit simultaneously. And so, for example, to light the first digit, we'll need to raise pin 12. And to keep the other digits dark, we would not raise pins 9, 8, and 6. Those would be tied to ground or low value. And depending on which number we want to display in the first digit position, we would have to raise and lower some of the segment lines to light up the appropriate segments. So that would display the first digit. And then a bit later, we would turn that digit off by lowering this pin. And at the same time, we would raise pin 9 to light up digit 2 and adjust the segments. So we would raise and lower the segments to display whatever number we need to display in the digit 2 position. And then we would keep cycling through. After we display digit 2, we'll lower pin 9 so that there will be no current flowing through these diodes here. And then we'll raise pin 8 and raise and lower some of the pins down here. We would lower the pins that we want to display. For example, if we want to display a 0, we would need to light up segments A, B, C, D, E, and F. And so with digit 3, let's say we're displaying digit 3, we need to raise pin 8, and then we need to lower pins for A, B, C, D, E, and F. So to keep pins, the G and the decimal point dark, we would have to raise these two. So we lower the ones we want to be on. And this is all very complicated, but the software we're going to use will do all of this for us, so we don't have to really worry about exactly which pins to light up. But I just wanted to show you what's going on inside of a 4-digit 7-segment LED display. You're also going to need some current limiting resistors. Remember that with LEDs, the more current you supply, the brighter it is, but you have to control the amount of current because with too much current you'll fry your LED. So what we're going to do is put resistors on the digit pins. We'll use 4 resistors, 1 on each of the digit pins. I suppose we could put the resistors down on the segment pins, but there are more of those, so it makes more sense to put the resistors on the digit pins. We can use a 330 ohm resistor. That's appropriate for an LED with a 5-volt power supply. If you were to just connect pin 12 to 5 volts and say pin 4 to ground, you'd have too much current, and this particular LED here would get fried real quickly. But by putting a resistor right here and right here and right here and right here, however the current flows, it will be going through the resistor. Let's go ahead and connect the 7-segment display to the Arduino. I've decided to use pins D2 through D12. I'll ignore the decimal point, so I've got 11 connections instead of 12 connections. Now, in order to keep things straight, you could make up a chart like this. So here I've listed all the functions, the digits 1 through 4, and the segments A through G and the decimal point. And here I've put down the pin numbers that occur on the part number that I talked about earlier. And here I put down the corresponding pin that will be used on the Arduino. And a chart like this is crucial so that you can keep your wiring straight. It shows how to wire, so pin 12 to 2 on the Arduino, pin 9 on the display to 3 on the Arduino, and so on. You can use the second and third columns to wire the display to the Arduino. And then when you get into the software, we can remember that pins 2, 3, 4, and 5 on the Arduino are digits 1 through 4, and likewise pins 6 through 12 are A through G. Okay, and that's a wiring chart like this is very helpful if you're using a part like I previously described. But in fact, I'm using a different part. I've got this LED display, and it is connected to what's called a breakout board. And as you can see, they have done the unscrambling of the wires. And I don't know if you can read this, but digits 1 through 4, they're actually labeled L1, L2, L3, and L4 on this part. And then you have segments A through G and the decimal point. So I've moved everything to a larger breadboard, and you can see that we've still got the LED connected to D13 along with the resistor to the ground pin here. And I've also got my potentiometer, okay, connected to the A0 input with the two sides of the resistor to ground and 5-volt power. And you can't see it very well here, but I have carefully wired the first digit, L1, to pin 2 on the Arduino right here. And then digit 2, 3, and 4 go to pins 3, 4, and 5 on the Arduino, according to my chart. And I've also added resistors here. You have to have these resistors because, as you know, any LED needs to have a resistor in series, or else you're going to burn the LED out. And so I have put a resistor on each of the common anode lines, so regardless of which segment is lit up, one of these resistors will be in line. And I've also wired the segments A through G to pins 6 through 12 here. So you can't really see that very accurately, but you'll just have to trust me that the A pin here, there's a wire that goes to pin 6 over here. And maybe you can see it with the last one. Pin G is this wire here. And if we follow it, it goes all the way over to the last pin, which is pin 12, D12. In order to operate our display, we could write a bunch of code to drive the Arduino pins up and down, but I think you're going to find that that's a little bit more complicated than you want. The typical approach is to go to the internet and look around for a tutorial or some examples, and I did that, and I found a package called 7-segment or SEV-seg that will do most of the work for us and make our life pretty easy. So in order to use it, we're going to need to download some functions. So I want to talk a little bit about the library functions. We've got a bunch of built-in stuff that's already there, like the serial begin and print line, as well as some of the other built-in functions that we have. And these are in a library somewhere that Arduino manages. But we're going to have to add some additional functions that operate the 7-segment display. To manage the library, we can go up to the Tools menu and we can click Manage Library, and it opens this little sub window here. Or we could do it by clicking this icon right here. So if we click that, we see a list of all the various packages that are available in the Arduino ecosystem. And let's just go ahead and search for this 7-segment, or really SEV-seg thing. And we find it right here. And this package here is what we want. And so we're going to click Install. And it downloads it, and it has successfully installed this library. So we can go ahead and close that. Now, if we were to go up to our examples, and well, you can't see it, it's off the bottom of the screen here, but it's added some examples from this particular package. So we can go ahead and open some of those programs that are provided with this package to basically get an idea of how it works. But I don't need to do that because I've already checked those out. And instead, I'm going to show you how we can use the functions that we now have available in order to display something on the display. Now, in order to make the 7-segment functions available to this particular program, we'll need to add something called a # include. And this has to be typed pretty much exactly as I'm typing it here. And we type 7seg with capitalization being respected, .h. And that will add the functions or make them available to this program. The next thing we need to do is we need to create something called a 7seg. Okay, so it's like a variable. So we use this name 7seg, again, with the capitalization as shown here. And then we can give it a name. Let's just call it my display. Okay, and we need a semicolon there. Okay, now we've got something called my display that we can use. This line right here is a variable definition. So it's very similar in form to something like this, where we're creating a variable called x of type integer. But here we're creating a variable of type 7-segment, and it's called my display. That's a name I just made up. 7-segment is the name of a type of object. Okay, so there will be an so-called object in the software that represents the display. And when we want to do things to the display, such as display a particular number on it, then we will apply functions to this particular object. So we see that going on down here with a serial. We're applying the begin function and we're applying the print line function to the serial object. For our display object called my display, we need to apply another function also called begin. It's a different function. It does a completely different thing, but it happens to have the same name. And this is going to initialize the my display object. It takes a number of arguments. And so what I'm going to do is I'm going to name the arguments. So the first one is something that has to do with hardware configuration. And then we need to tell it the number of digits that the display has. And we need to tell it which pins on the Arduino are used for the digits. And then we need to tell it which pins on the Arduino are used for the segments. And we also need to tell it something about whether we've put the resistors on the segment lines or the digit lines. So this begin function will initialize the display, and it will do sort of something in software to get things set up so that we can display on it after this. Now, I'm using names here. I could, this is just a number. I could and very well just type 4, but I think it's clearer to create a variable called number of digits, and that's an integer. So we can set it to 4. Okay, this begin function requires an integer here. Now, what about hardware configuration? So that is a variable of type byte, and we can type hardware configuration here. And we've got something with a common anode. Our product, our little breakout board, has all the anodes wired together. Other displays have the cathodes. So this 7segment.h that we've included up here defines some names. And one of the names it includes is common anode, as spelled like this. And it also includes common cathode as well. But we'll use the common anode name. Okay, next we need, let's do the resistors on segments next. That's a variable of type bool. Boolean variables are either true or false. So I could just put in here true or false as we want. But I think it's easier to create a variable here with this name and say it's true. Now, in fact, I put the resistors on the anode lines, but this software has this comment here that comes with it that says set it to true for multi-digit displays. I don't know what's going on with that, so I just set it to true. Next, we come to digit pins. Okay, here we're going to define which pins are used for the digits. So again, we have a byte variable, so it's only an 8-bit integer, and it's called digit pins, and we're going to set it. And this is not just a single value, but it's actually a list of values. It's an array. And so when you see brackets like this, it's an array. And so here I'm going to give it the list of pins that I'm using for the digits. And I was using pins D2, D3, D4, and D5. And we need a semicolon here. And so this creates an array called digit pins that contains 4 different values, 2, 3, 4, and 5. And those are each occupying 1 byte of memory. And this is being passed as an argument to the begin function. And the next thing we need is the segment pins. And so for that, we're going to do something quite similar. We're going to create an array. So there are 2 brackets, and we're going to initialize it. And the pins that we used for the segments should be listed here, A, B, C. Now, I've arranged things so that we're using pins 6, 7, 8, 9, 10, 11, and 12 for the segments for A, B, C, D, E, F, and G. If we had the decimal point, we would put it in here. I'm using pin 13 for the LED, so we could just leave that out. And I think that's good. So what else do we have? I think that's everything we need. I probably ought to do these things in order. Hardware configuration, number of digits, I'm going to move it up here. And then I'm going to move resistors on segments down after that. And then I'm going to adjust my indentation like that. And so hopefully, let's just check this and make sure I got that right. Okay, done compiling. I didn't make any mistakes there. The next thing to do is to set the brightness. So there's a set brightness function that we can apply to this display object. So we'll just type brightness here. And it takes a number between 0 and 100. So let's just document that from 0 to 100. In my experience, this doesn't necessarily work correctly. Certainly, I've misspelled it here. If I try to check this thing, it's going to complain. It says set brightness here. Boy, it doesn't like this. It's underlining it to show where it's having a difficulty. And furthermore, it's nice enough to suggest what it ought to have been. And in fact, that's really correct. So let's close that. Get rid of that, and let's go ahead and fix that. And so I don't know if this really has any effect. In my previous experimentation, it didn't seem to make any difference. Another thing that I wanted to mention was that the order that you specify these numbers within the digit pins array matters. Okay, they have to be in the order of whichever pin you used for the leftmost digit, digit 1, followed by digit 2, followed by the pin you used for digit 3, and finally the pin you used for the rightmost digit, digit 4. And likewise, the pins that are specified, or the numbers that are specified in the segment pins array, had better be in the proper order for A, B, C, and so on up to G, and then the decimal place. Now, I wonder if it's going to cause any problem with me failing to put something in there for the decimal point. Let's just keep going and see if it works okay. Now we're ready to get something displayed on the display. And for that, we need to do two things. First of all, we need to invoke this function called setNumber, and then we have to refresh the display. So within our loop, we need to keep constantly refreshing this display. So let's take care of that first. My display, and the name of this function is refresh display, and it takes no arguments. So this will constantly be updating the display. Remember that all those segments have to be lit up, the digits have to be lit up in turn, and so on. The software is going to take care of all of that. And the next thing we need to do is figure out what number to display. So before we display it, we need to set the number. So that's a function called setNumber. Whoops. And let's just try 1, 2, 3, 4 just to see if this thing is going to work. And the other thing is this delay here, which I had for the print line, is going to cause some problems. Maybe I'll come back to that, but let's comment that out for now. And now let's go ahead and give this thing a try. So we'll go ahead and plug in the Arduino, and then we will click Upload. So it's compiling, no problems. And now it's uploading. And let's see what happens here. And the camera image is picking up the flickering, so I don't know whether you can see this or not. But you can actually, I cannot see with my eyes the flickering, but my camera seems to be picking it up. So you can see that this thing is flickering. So let's go back to the program, and just to make this more obvious, let's take out this delay here. I'll change it to 100 milliseconds. And now let's re-upload that, and maybe this will make it a little bit more obvious what's going on. Now you can see that each time the loop executes, it refreshes the display, and that displays one digit, and then we wait for 100 milliseconds, and then the loop is called again, and we display the next digit and wait 100 milliseconds. And that allows us to see each digit being displayed in turn. All right, now instead of displaying 1, 2, 3, 4, we want to display the voltage. So let's begin by commenting out this delay. And then here we want to display the voltage. That's a number between 0.0 and 5.0, but we really want to display a 4-digit integer. So let's go ahead and multiply this by 1,000. And now we've got a number between 0 and 5,000. So that'll give us a 4-digit display. And I think that should work. So let's go ahead and upload that, compiling, and it's uploading. And we see that we have 5. And again, to my eye, that is not flickering. That's just an artifact of the camera I'm using. And if I turn my potentiometer, we see that it varies. Now if we go all the way down to 0, we'll see that this number is getting displayed as just several digits. And that's not really what I want. So let's see if we can fix that. Now I'd like to display the voltage as a full 4-digit number, and if it's less than 1, I want to display it as 0.002 or something like that. Now it turns out that there are some additional arguments that you can put into these function calls, and the only way you can know this is by just looking at the examples and kind of looking around. But it turns out there are some additional arguments that I can put in here. One is called update with delays. I have no idea what that is. And then the other one is leading zeros. We want that, leading zeros. And then finally we've got disable decimal point. We want to actually have the decimal point, so we will have to change that. And now this is flowing over one line, so what I'm going to do is I'm going to break the line here, and then let's indent it a little bit so it looks nice. And now I've got to define these additional things. So disable decimal point is a Boolean variable. Disable decimal point. and we want that to be false. We do not want to disable it. We want the decimal point. And the next thing we have is update with delays. Update with delays. And that we want to set that to false. And that is also a Boolean. So we'll do that. And it says, the comment says that the default false is recommended. And, so not sure quite what that is. But I'll put that comment in there a little bit so it'll be there. And then let's see, the leading zeros. We need leading zeros. That is also a Boolean. So, whoops, we type leading zeros and we'll make that true. We want the leading zeros. And now there's another aspect of this display, the set number function, and that is you can put in where you want the decimal point to be. So I think it's an additional argument to this function. So this particular function, set number, can either have 1 or 2 arguments, and the second one is where you want that the decimal point to be. I think that 0 would probably be no decimal point. 1, 2, and 3. Let's try 3 and see what we get. So I'll go ahead and upload this. And this is a style of what is this? Disable decimal point was not declared. Okay, so I must have misspelled disable decimal point. I spelled it differently here, and we've got to not do that. So let's try again. Yeah, this is the style of programming in the Arduino. Sometimes you just make changes to see what happens, and that works okay. All right, it's uploaded, and now let's crank it down to 0. That's fine, but I'm not seeing my decimal point. Oh, I haven't wired it. That's right. This last parameter here is the pins for the segments, and I just did A through G. And now I need to use a pin. I'm using 13 for that LED. So let's do 14. That's free and available. And so I'll have to put in a wire. So I'm going to add a wire from here to... Wait a minute. I have to stop and think. Is that 14? I think 14 is right. 14 is this green wire here, the A0, if I'm not mistaken. So I think we really want 15. So let me put in 15. And let's upload that and see if that gives us any different result. I think I have the Arduino pin out here. So I can look. Yeah, 15 is right next to A0. Oh, and our decimal point is in the correct spot. So that's looking very good. So we can go down to 0.0. And now the last thing we wanted to do was we wanted to turn on the LED when we reached a threshold. So for that, we're going to have an if statement. So an if statement looks like this. It's got if and then a couple parentheses and then a brace and a closing brace. And so we've got that set up. Now what we want to test here is whether voltage, and we can say whether it's greater than or equal to, let's just say 2.5. Okay? Voltage is, if it's greater than or equal to, let's make it nice and even. Let's make it 2.0. Then we want to turn on the built-in, the LED. And we've got that configured as pin 13. So we'll do a digital write to pin 13. And I prefer to have 13 here directly. And we've also got the situation where it's less than. In that case, we want to turn our LED off. So the format of the if statement is you have the then part, and then you can have an optional else part. And we don't need that extra brace. And so I'm going to put that there. And if the voltage is greater than or equal to 2.0, then we're going to turn pin 13 high. And if it is not, we're going to drive the LED pin low. So Let's just go ahead and try to upload that and see if that achieves what we want. Okay, so the light is on and we're going down and we get below 2 and it goes off. So the LED comes on when we are above a certain threshold. An if statement is really composed of several parts. You've always got this form, if, open parenthesis, and then here's the condition, and then a close parenthesis, and then an open brace, and a close brace that matches it. You can have only a then part. Here's the then part. And you can also have an optional else part, which is these two lines here. So this part that's highlighted is optional. The conditional here can be a number of different things. And then after that, for the then part, you can have one or more statements. And if the else part is included, you can have one or more statements there. So the idea is that if this condition is met, these statements will be executed. And if the condition is not true, that is, the voltage is less than 2, then the else statements will be executed. I was a little surprised that the LED was flashing in the camera, and it occurred to me that the problem is with this serial print stuff. That's actually quite a bit of code there that's being executed. We're still outputting stuff to the serial monitor, although we're not looking at it. In fact, if I go up and open it, let's see what it'll say. If I look at the serial monitor, yeah, we can see what's happening. So let's go ahead and comment out the stuff that's relating to the serial monitor. And we'll go ahead and upload this and see if that has any impact on the flickering. Oh yeah, it stopped the flickering on the camera. So it looks like this program is working the way we want it to. And so I hope you've learned something about how the Arduino IDE works and about the general style of programming the Arduino. And I want to close by saying thanks for watching and have fun playing with your Arduino.